So somebody asked me about the cost, and I'm gonna take you guys through like a hypothetical. This is actually very similar to a system I'm installing now. So imagine a residential system, 21 panels, 280 watts per panel. That would be a solar system. So the power rating is 5,880 watts. How do I get that number? The watts per panel multiplied by the number of panels. Assume a price of $3.20, which is a pretty normal market price these days. That system would cost $18,816. The federal ITC, the investment tax credit, gives the customer 30% of the cost of the system back on their income tax. So they get basically $5,645 back on tax season. So out of pocket, they really end up spending $13,171. At an 85% efficient rate, which is very high, but normal with a DC power optimized system. Going from the powering of the system to the energy production of the system, we get 9,486 kilowatt hours per year. We valued a kilowatt hour locally at 12.5 cents or $0.125 per kilowatt hour. That's what we found that FPL charges per kilowatt hour. In other words, when you want to figure out how much the monetary value that your system is producing, you want to look at how much energy it's making, and that's the energy that's saving you from buying from the utility. And one thing that was mentioned by the mayor was protecting yourself against inflation. And in our case, inflation means FPL increasing their price. And we found that to be 5% per year. So the ROI, the duration of time that this system pays for itself is 9 years, and I'll show you guys some of those assumptions. Basically, this is from the Bureau of Statistics and the U.S. Department of Labor. This was a publication that came out in December of 2014, and they basically study energy prices all across the United States, different types of energy, gasoline, electricity, gas. And so, it shows Miami area versus the United States average. We are a little bit cheaper, slightly, but that's where we get the figure of 12.5 cents per kilowatt hour. So that's a real figure, that's brought to us by the U.S. Department of Labor. And this is where we get the 5%, expected escalation for FPL prices. And it's a little dated, right? So 2009 was our forecast where we got it. But we've checked it out, and it's pretty spot on. So FPL talks about dropping their prices, but so the way that this works is we know how many kilowatt hours we're making year one, and we know the current value of a kilowatt hour. And so we multiply the number of kilowatt hours, the amount of energy that is produced over a year, by the value of a kilowatt hour, so that system produces $1,186. Assuming it's going to make around the same amount of energy every year, the value of energy goes up because it's offset, the cost went up.
You're just assuming net metering?
This is assuming net metering, yes.
Can you explain how that policy is right now and what the challenges are and how it's going to be?
So net metering means that FPL legally has to come out and swap out the meter that everybody currently has, which is a unidirectional meter. It only counts energy going from the grid to the home or to the building, to a bidirectional net meter, which means a meter that can count energy both going from the grid to the home and from the home back to the grid. They change out the technology. The way that it works is we get a building permit to build. We build. We get the system inspected by the building department. The authority having jurisdiction. They sign off. They say, okay, your construction project is complete. You have, you built it per the drawing. We approve it. Then our customers, because the person with the FPL account submits an application for net metering and a net metering agreement to FPL, along with the paperwork saying that the authority having jurisdiction has approved the project. Then FPL comes out and swaps out the meters to a net meter. So what a net meter does is it counts energy going, you know, in both directions. And that's important for us to do, because our demand and our production is never, you know, one-to-one. So, you know, the parents are at work, the kids are at school, you're making all the solar energy, barely using energy at home other than, you know, cooling your refrigerator. You pump all that energy back onto the grid. Your meter spins backwards. Now it's nighttime, you don't have any energy being produced by your solar array, you pull it all off of the grid. Right at the end of the month, you're accountable for that net difference. You know, so if you took more energy off the grid than what you put on, well, you pay for that difference. If you put more energy back on the grid than you took off, you get rollover minutes every month until 1 year goes by, then you settle the score. I tell my customers should go as high as possible to 100%, maybe go a little over 105, 110, but not to aspire to produce 200% of their consumption. Because, like the mayor said, the FPL is going to pay you 3 cents per kilowatt hour, where they charge you, you know, around 12. So that's a bad deal. So offset your own consumption as much as you can. Don't try to make money off of the power company. They're like, we're the power company. You're not the power company. I'm not buying from you the product that I sell. You buy my product. Yeah.
2 questions. One, if I wanted to do this for my house, I wanted to look at this space in my house, and I wanted to kind of figure out how many ways I can look for that this makes sense. Those are the things that actually go with the Excel spreadsheet. That was my second question.
Goldin Solar, GoldinSolar.com, GOLDIN We do free proposals, we do free site visits, we'll go to home. My thing is, I believe in getting off fossil fuels. I think solar is the most promising form of technology to promote sustainability and offsetting our carbon footprint. But I, you know, promote it as an investment, and the stuff does pay for itself. And I like to give my customers a comprehensive idea of the return. I like to show them how many panels they can fit on the roof. You know, we look at the energy consumption. We say this is how many panels we recommend putting on, et cetera. So we do free site visits. Yeah.
I would think typical fields, but since you're creating current, right, because you're running photovoltaic to current, won't that kind of like produce some kind of like magnetic field that could be harmful to certain people, like pacemakers or something around the home? So another question is there a max energy a certain household size can produce so what it's safe? Or is there any health hazards associated with too much?
The National Electric Code used to cap it at 600 volts, and the new National Electric Code is capping the maximum voltage at 1,000 volts, but that has nothing to do with health and risks and hazards. You know, they put in a bunch of wind and they found that it made a resonance sound that bothered people. I've never heard of a magnetic field from solar arrays that has been disruptive. Never heard of it. And you'd assume that with all the solar going on in all the world, if this was an issue, it'd come up. But there's enough enemies of solar to call out a problem if there is one in solar. So the fact that, you know, they have plenty of problems to make up, if there's a real one, they'll find it.
It won't be more than any wiring or transmission line.
Absolutely, exactly. Yeah.
The Rolex in your attic is going to put out a higher field than the solar.
The Rolex?
It's the lighter. Typically, people are running power on the camera.
Oh, okay. So there's no health hazard.
No.
Producing much more than you consume.
No, your espresso machine and the freezer are the most dangerous things in the house for magnetic fields.
Really?
Oh yeah, and if rats work in espresso bars, they do that. Don't spend too much time looking at the hot press with the freezer door open. That's where your big magnetic fields are. Don't spend a long time with the freezer door open. Your parents will tell you anything.
Okay, well, success. No health hazards.
There was one thing that came up in the news, but it was from a concentrated solar mirror farm, I think in Arizona, and that was birds were catching on fire. Flying careers and turning the ball on fire. You heard of that?
Yeah.
Oh, water too. Yeah, that's concentrated solar. That's not photovoltaics.
Concentrated solar, so like the reflection from the.
It's mirrors that concentrate light into
Oh,
one central
right.
point that each water that's been turned
That makes sense.
Have you heard about the clear transparent solar panels that are coming out?
Yeah, I mean, you catch stuff on the news every once in a while, but a lot of stuff trends. And as a business owner, you try to like read these articles, but you're not gonna just sell everything and try to push something that you happen to read on Facebook. Everybody remember solar freaking roadways? Anybody see those? I don't know. My car's not transparent. I don't see how that works, and I sit in a lot of traffic. And I try to think about it. Roads have to have some friction, so that if you ever slam on brakes with the rain, you don't slide all over the place. But things that have friction aren't transparent, and they have to be strong enough that you don't break the solar cells under the weight of a truck. So, there's a lot of gimmicky stuff out there, but what's on the market and what is getting done is what's withstanding the test of practicality and time.
Yeah, I have a question. You mentioned that you want to be in the annual business. Is this program something or how does that
For a dynamic system?
Yeah.
Well, there's different ways of doing it. One is on a timer, and one is with a weather observation station. So it's basically designed to always stay perpendicular to the sun. However, that's really more of an application for utility scale solar, for large, thousands of solar panels. On homes and buildings, we put in static systems.
And the other one is hurricane, and very specific instructions for everything
With solar panels? When a hurricane's coming, go to the houses with solar panels because the added rails on the roof, coupled with the stringent requirements by building departments in South Florida, basically reinforce the structure. It's more likely that the entire roof of a home will rip off than that the solar panels will rip off the roof. We design our stuff for 175 miles per hour wind speed with a safety factor of 2. We're ready for a double engine.
You mentioned that the panel actually increase the homeowner's value, right?
Yeah.
Would that also, how does that affect the insurance? Is it like structural, I'm really trying to more the question, right? Is that gonna drop your insurance, raise your insurance? No, that's not a question.
You might be better to answer that question because I don't personally have experience with that information with some of the insurance rating.
I don't think the value of the array is high enough to matter. The replacement cost of my array is, probably, if the array, the entire roof came off, the roof costs more than the array does. And the damage to the contents of the house is going to cost more than either of them. So, it's not a big deal. I mean, solar's not cheap.
Right.
You're talking about structural integrity, so does that mean certain structures in homes can't really handle solar panels?
My kind of rule of thumb is I wouldn't put solar on a roof that's more than 30 years old. You take a look at the roof, you take a look at the attic, you take a look at the rafters. If you see any rotting, don't mess with it. If the roof tiles look bad, don't mess with it. But these are things that every homeowner is very in tune with. People know the conditions of their roofs. If there's leaks, people know them pretty much instantaneously. And I've had customers come to me and say, I really want to go solar, but I want to replace my roof, so maybe I should get that done first and then do the solar. And I say, no, call us both at the same time. I'd like to work with your roofer so that we can get the stands, that the rails rest on, installed at the same time as the roof. And that's the way to do it. But for the most part, most roofs are solar ready. The best roof to go is a standing metal seam because we don't even have to penetrate the roof. There's special clamps that just bite down onto the seam, and that's the nicest way to go.
Yeah, you still want to have your roofer, roof for solar because they'll add extra clips. the standing seam roof, a double the clips in order to prevent the uplift. And we take the extra weight. So we want to design it into a standing seam roof.
So, okay, so we were talking about the return on investment. Basically, I just showed you 10 years up through when it's actually paid back. But here's what the graph looks like. And I graphed it out for 25 years, reason being that's what the panels tend to be warranted for. And so I had a customer that said, yeah, I have the money for it now. I'm kind of thinking about doing it, but I just started this fund for my daughter to go to college, get a newborn. And I said, okay, cool, let's build solar, and the money that you save on your power bill you can put there and basically triple the investment. And we showed him how that worked, and we just finished building that system. So you go through the zero, it's paid for itself after about 8 or 9 years, and once it's paid for itself, it continues to generate revenue and energy savings. And that's not even talking about the added home value, which there have been studies that have been done to show how much the home goes in home value, and the conclusion is about $4 per watt. And most contractors sell solar under $4 per watt. What that means is that your home goes up in value by more than the cost of the system. So we've all heard that, a vehicle is a depreciating asset. It drops in value the second you drive it off the lot. Well, this is exactly the opposite. The home goes up in value by more than the cost of the system as soon as the installation is complete, and it pays for itself.
I wasn't sure when we started, did you mention that you've been working on projects that are you?
No, I was going to kind of talk about potential at FIU.
Okay.
Yeah, I haven't done anything at FIU yet. So, yeah, it's a good segue. Thank you. So, basically, I showed you guys a sample return on investment calculation for a residential system. That doesn't necessarily apply to FIU, and the reason is it's different. FIU pays a different rate for energy because of the volume of energy that it purchases. But, we have to look at basically a whole different purchasing structure. There's basically power of numbers, the number of students here, and we have to think about the other benefits besides the environmental benefit and the financial return. The educational element, we could have screens in every building showing real-time energy production and graphing that out. I think that'd be something kind of neat for a place like a school. Miami Children's Museum did that. And of course, the ability to take pride in leading the community to the transition to clean energy. Florida International University is the state school of South Florida. I think that's fair to say. And South Florida has been called ground zero for climate change. I've heard the description that says that South Florida has more to lose in terms of real estate dollars per rising foot of sea level than any other place in the world. And yet, we seem to be kind of oblivious to it. So, it would make sense that the hub of academia and education in South Florida would lead the way in saying, we're going to take the bull by the horns, and we're going to do this solar thing, and we're going to tell everybody else that it makes sense, it is feasible, and it is worth doing. So, it'd be cool to see that at FIU. So I used some software to kind of show some hypotheticals. Basically, this is real layouts. This is a software that we pay for license. We can go in. It's a neat software. It's got a plug in Google Earth and a library of every solar product that's ever in the market. So we go in and we say this is the area we want to do. We correct the azimuth and the tilt, and we tell which solar panel we recommend, and then we tell the keep outs. So we see air conditioning and we say don't put them there. And then we get proposed systems. So this would be a 771 panel, 255 watts per panel for a total of 196.6 kilowatt system. This could make 317 megawatt hours a year, or 317,000 kilowatt hours a year. And looking at some historical data of FIU, this would be about a little under 20%. Does that mean that FIU can never hit 100% solar? Absolutely not. You still have parking lots which you can cover solar. There's lots of places to put solar panels.
So when you say 18%, you mean 40% of the building unit, okay.
Mm-hmm.
And what are those circles?
Those circles represent inverters.
Oh, okay, where do we place?
Well, they don't necessarily have to be placed there. You know, you can take them over to the side. But one of the things that we do with the software is not only lay out the panels, but we figure out the electrical string. So it figures out how many inverters and the optimal electrical layout.
My daughter is an electrical engineer.
Fire.
So you will sit with the offer that was going to be there for you to sign up for the program, offering internships for students to work with the company and learn about the system and how it works.
One of my takes on this is that for solar to work at an institution as large as FIU, it needs to be student driven. And the reason is that there's a lot more students than administrators. And you know, I've understood that because FIU pays relatively less for energy, and I'm not 100% sure if FIU is eligible for the federal tax credit, right, because it's a non-profit establishment, right? And that changes the financing completely. Does that mean that solar could never work at FIU? Absolutely not, but it means that we have to change the way that we approach it. And so one thought that I had, for example, is, and I looked at the numbers, right? So according to Google, there's 47,736 students enrolled in FIU in 2014. Now it's 54,000. Okay, cool. Well, I did some calculations without but all of course, let's say, and this is an assumption, that each student took 15 credit hours per semester. Right, so if you multiply the number of students that were enrolled in 2014 by 15 credit hours per semester, that's 716,040 credit hours per semester. So what if we charged each student $1 per credit hour voluntarily, right? What if students sign a petition that they want to do this? What's $1 per credit hour, right? $15 a semester. And allocate that money towards putting solar panels on FIU buildings. It sounds crazy, but it could work. And what would you do with $716,000? You would build both this and and another one. You could completely cover at least 3 buildings at FIU. And you could do 3 buildings per semester. And that's only by putting $1 per credit hour. Then, you know, it shouldn't be a one-directional deal, right? FIU pays the students back and the energy savings, right? So because you're tracking all the energy savings that you're getting, that fund can either go back into the solar fund or towards student activities. So just because FIU can't get the 30% federal tax credit doesn't mean that there isn't some neat mechanism that can basically be put in place to make solar work. That's kind of my take. So this is a layout designed for the convention center.
In your experience, has there any been risk of like electrical mishaps? Worst case fire? I doubt it, but is it more likely with these systems installed in the building? Because it's already like, you know, a system installed in the building itself.
Yeah.
If you're adding another system, could it be possible that you may have an overload somewhere or a short circuit? I don't know.
The general take on that is that any risk associated with solar, and of course, you know, by itself it's extremely dangerous, but when it's thought out by, you know, the greatest electrical minds in the world, they find solutions to all these problems. Every inverter to be solar installed in the United States has to be equipped with rapid shutdown. That means that if a fault circuit is detected, the system shuts down in milliseconds, literally hundreds, thousands of a second. That stuff's all thought out. Every inverter, according to Underwriters Laboratory, the testing agency of the United States, any inverter to be solar manufactured in the United States has to be equipped with something known as anti-islanding. Anybody ever heard of that? Anybody knows what that means? Anti-islanding. Islanding. Basically, you know, a customer said to me, okay, cool, I have my grid-tied solar system, no batteries, sweet. So the power goes out, I still have power, right? The answer is no. And the reason is, when the power goes out, there's going to be workers working on the grid, working on the lines, and you don't want to be sending power back to the grid. You don't want to be backfeeding power. And so, yeah, so the inverters have to be equipped with a mechanism that shuts them down when they don't read power coming in from the grid. So yes, potentially there'd be lots of hazards, but my take on it is they've been thought through and the solutions have been in place. Yeah.
I just wanted to comment on being supportive of the idea that you just brought up about putting solar panels on roofs. I used to actually work on like a national coalition where all these college campuses were going green, and what they would do is they would actually like put a resolution together. It's pretty simple, and pass it through the student government. Sometimes, depending on the way the administration set up, you work with your administration to do it. That you can do a few dollars per semester going towards solar or green energy or other things. And just there's tons of campuses that have done that across the country. So yeah, it's totally been like student-led a lot of this.
Right.
And it's really good for the industry too, because these are big buyers of energy. So it really, if they talked, it started like 10 years ago, and it was like, at the time, it was like just starting to be done, but these are huge users of energy, so it's really driven a lot of the price to go down in the whole industry overall. So it's a really great thing.
So I had lunch with President Rosenberg today, and also Mayor Cindy Lerner, and Mayor Lerner quoted to him and says, okay, you're doing all these projects with FPL on campus. FPL is a call center on campus, and they train our students to answer the telephone, hired. She says, well, are you willing to do model solar installations on the campus? And we talked around in circles for a while, finally said, let's discuss it. So I told him, call back again the question, I want to be there. So maybe we'll have him come in as well.
I'd love to be there. We'd love to build solar at FIU. We'd love to bring students on board to build with us. We'll pay them to build, and it to be combined as an educational opportunity. And we'd have real-time display of all the energy being produced inside the campus buildings. Go green and high tech, and lead the way for South Florida.
My other question is a bit on my part.
Absolutely. I'd love to talk about that when we're done. Absolutely. Specifically for the privilege to build in the city of South Miami.
What laws in the state of Florida is in the business, doing the business, the kind of work that you do? What are the laws in Florida that really you see need to change in terms of putting out this proper role and doing it in this way?
The biggest thing is what the mayor spoke about, which is known as power purchase agreements. It's having the ability to sell energy to a third party. I'm allowed to install solar panels on my customers' homes, but they own the systems outright. I can lend it to them. I can bring in a lender so that they can buy it, but I cannot install it on their homes in such a way that I pay for the materials and the labor for the installation, and then only charge them for the energy of the installation. I can't do that. That'd be considered a power purchase agreement. So that's the big push. And solar is such a viable technology, and it speaks for itself so much that there's actually a Tea Party involved coalition that's pushing to free up power purchase agreements. So it's pretty amazing to see bipartisanship on solar in Florida. So we're moving forward. That's the good news.